Good evening, SCSU Physics. It's your boy Owen here with the answer to problem number 5. So we're going to start with a picture. We have a glass of water, we're going to have a calorimeter in it, and an ice cube. So we'll also start with our givens. We'll have our masses, initial temperatures, and specific heat capacities of our 3 different materials. We've converted all of these into kilograms instead of using grams. And these are all going to be in Celsius. And then here we just have the specific heat capacities of each material. And a quick little update for you guys. That's not a calorimeter, that's a temperature probe. Calorimeter is the copper cup that it's sitting in. Okie dokie. Now that we have our givens, we can move on to our equations. We're going to be using Q equals mass times specific heat capacity times the change in temperature. We're also going to be using Q times mass times the latent heat, and we're also going to be using the Q gained is going to be equal to the negative Q lost. So we can start with the calculations for ice, which is going to start off at negative 78 degrees Celsius, and it's going to be transitioning to 0 degrees Celsius. And then once it gets to 0 degrees Celsius, we're going to go through melting. So it's going to be 0 degrees Celsius to 0 degrees with the latent heat. And then finally, we'll go from 0 degrees up to our final temperature. So to start with, we use Q equals mc delta T. So we have our mass in kilograms of 0.04 times our C of 2090 times the change in temperature. It'll be going from negative 78 to 0, so that's 78. We can figure that out to be 6,520.8 joules of energy that will be gained by the ice. Next, we'll move on to the melting. So for this, we just need the mass of the ice, which is 0.04 again, times the latent heat of ice. So that'll just be our L value of 3.33 times 10 to the 5th power. I write it with ease if that's confusing. So that'll give us 13,320 joules of energy in that transition there. And finally, we're going to be going from our 0 degrees to the final temperature. So we'll use, we'll use Q equals mc delta T again. So our mass of 0.04 times the C of water, because now this is water, it's no longer ice. So we'll use 4,186 times the temperature final. So with that, we get 167.44 times the final temperature. That'll come into play later. Alrighty, so now we can move on to the water. So for the water, it's going to be the same as the first and the last stages of ice. We're going to use Q equals mc delta T. So we have our mass in kilograms, 0.560 kilograms, times the C value of water, which is 4,186. And we'll multiply that by the change in temperature. And we'll have to use the final temperature minus the initial temperature. So that'll be temperature final minus 25. Work out the algebra on that, and we get Q lost by the water, because the water is going to be going down in temperature. It's going to lose energy. That'll go to 2,344.16 times the temperature final minus 58,604. Finally, we will find the energy lost by the copper calorimeter. So that'll be the same as the water. Q equals mc delta T. So 0.08 is our mass, 385 is our C value, and then temperature final minus 25, because that's its initial temperature, and we're trying to find the delta T. So the Q lost is going to be equal to 30.8 times the temperature final minus 770 joules. Now that we have all 3 of these, we can look at our final equation up here. So the Q gained by the ice is going to be equal to the inverse of the Q lost by the water and the calorimeter. So we can add up these 3 values here and plug it in on the left side of this equation, and then we will add the energy lost by the water and the copper calorimeter and put that on the right side of this equation. So with that, we get 6,520.8 joules from up here, plus 13,320 joules from in the middle here, plus the 167.44 times the final temperature from here. Note these are all different phase changes, I believe was the proper terminology. So that'll be just the 3 stages that the ice goes through. And then we move to the right side. We'll be adding up the 2,344.16 minus 58,604 joules, and then we'll add that to 30.8 times the final temperature minus 770. And note this entire side of the equation is going to be negative according to our equation here. So we'll just put that in brackets and make it negative at the end. And down here we have it times -1. So then we just do some algebra, get it down to 2,542.4 temperature finals equals 39,533.2 joules. So one more and we get our temperature final is 15.54 degrees Celsius. We round that down to 16 degrees Celsius using sig figs. I hope that all made sense. If it doesn't, please yell at me. Goodbye.